Hello, everybody. My name is Jessica. I'm going to be the primary presenter for this presentation today with Andre. We are going to give it a few minutes before everybody to come in before we get started, and then we'll be good to go. So I will wait until approximately 9:03. All right, everybody, thank you so much for your patience. We're going to go ahead and get started. Welcome so much to the Human in the Loop Generative AI Lab training session. My name is Jessica Doucette, and I am a product manager for Gen AI. I'm presenting today with Andre Fair. First things first, we're going to go through a quick little introduction to everybody here. We have a number of people also in the chat here to help out. So first, I will introduce Andre Fair. Andre is an orthopedic surgeon with a PhD in general medicine. He also happens to be our lead annotator. He's been with the John Snow Labs team for a number of years now. In the chat, we have Amit Shrestha, one of the lead data engineers that works specifically with Generative AI Lab. He's been with us for the past 3 years. We also have Alexei Zakharov. He's a neurologist and a data annotator here at John Snow Labs. He primarily works on healthcare models, and he's been with us as well for the last 3 years. Lastly, in the chat, we have Dia Trambitas. She holds a PhD in computer science. She oversees all of the product development that happens here at John Snow Labs. This powerhouse team has been working at John Snow Labs and on the Generative AI Lab product throughout its many names over the years. They've developed both clinical and research models for General Electric, Pfizer, Oracle, and many more using the tool that we'll be working with here today. Not to leave me out, my name is Jessica Doucette. I'm the new product manager here at John Snow Labs, and I work specifically with the Generative AI Lab tool. That will be the focus of the presentation here today. Just a little outline of everything that we'll be covering here today. First, we'll be doing a quick introduction to text annotation, and then we'll start building our project. So we'll start choosing your models, your rules, designing prompts, and then we'll start with a proper project setup for an annotation project. We'll go through the nuances of pre-annotation. Andre will help cover the annotation guidelines, and then it'll be back to me for the model training and testing, as well as generating augmented and synthetic tasks. At the end, we'll have a quick little demonstration of our de-identification tool, and then we'll open up the floor to Q&A. So of course, everybody in the world, I think, is pretty familiar with AI at this point, but even me, I find myself using terms interchangeably when a more specific term is available. Since we're going to be in the thick of it today, I thought we might want to go over just some broad definitions. Of course, artificial intelligence, AI, is referring to technologies that allow computers to mimic human behavior. You'll see this in the response of LLMs and pretty much anything else that's labeling itself AI these days. Machine learning is the backbone of these outcomes. It's the statistical techniques that are required to ensure that AI improves over time. Machine learning models make decisions based on sample data. The sample data should, of course, come from domain experts like yourselves who are highly trained, which is the crux of this human-in-the-loop training that we have today. Other terms that we'll be using are often NLP, natural language processing, which enables machines to understand and generate human language, facilitate communications through tasks like entity recognition, sentiment analysis, and translations. Deep learning is a branch of machine learning that employs the multi-layer neural networks to analyze complex data patterns, and conversational AI technologies enable machines to engage in human-like dialogue. Lastly, of course, we've got the LLMs, advanced AI systems trained on vast text data, is that we'll be having a look at most of these throughout our presentation today. Now, the specific part of our presentation today is human-in-the-loop. Human-in-the-loop training is an approach to machine learning where human input is integrated into the training process. This method combines the strengths of automated systems with human expertise to improve model performance and accuracy. At a high level, it involves humans providing feedback, annotations, or corrections during the training of a model. For instance, when a model makes predictions, humans review those predictions, identify errors, and suggest improvements. This iterative process helps refine the model by incorporating nuanced understanding that automated systems might miss, especially in complex or ambiguous scenarios. Human-in-the-loop is particularly useful in areas like natural language processing, where context and subtlety can greatly impact the results. By leveraging human insights, models can become more robust, accurate, and better aligned with real-world application. In today's training, we'll be showing how human-in-the-loop training can improve an NER model. Of course, nobody would be here today if it wasn't for data annotation. And I know you are all familiar with what that is. And you also know how time-consuming it can be. So I hope what I show you next will be as useful to you as it is to us. Here, of course, you can see what our annotation view looks like. This isn't a perfect example. You'll see some of the entities are hard to read, but the purpose of today's demonstration is to really get you to make the most of the product. Here, I'm going to move over into the actual product here for my demonstration. And you'll see just really how simple it is to pre-annotate and get started. And you'll never have to start from scratch. So I'm going to just sign in. And when you sign in, you'll be able to see all the projects that are available to you. And typically, once your project is already configured, once you click sign in, you'll be brought straight to the tasks page. Here you can see these are incomplete tasks, and these haven't been annotated at all. Navigating back to the tasks page, so that nobody is starting from scratch, we just go ahead and select our pre-annotation server, and we go ahead and select pre-annotate. And we'll get into all of the settings here that make this happen super quickly, but we'll be able to see here in the next minute that this pre-annotation is running on each of these tasks. And when it's complete, we'll click in and see all of the work that's happened. Perfect. You can see that it's complete, and I'll just go in and click in. And this is the pre-annotation server. Now, it's not meant to be perfect. We're trying, but the whole purpose of this is, of course, for human review. And this is all of the work that is saved by using pre-annotation. Our product offers a variety of different types of project. We have entity recognition, assertion status, text classification, emotion detection, relation extraction, de-identifications. We have, there's many more, filtering long label lists, text summarization, etc. is all available within the product. So quickly to round out our introduction here, we have why data annotation is so crucial for natural language processing, of course, is for the transforming of unstructured data. We have tuning unstructured data into organized, structured formats for better analysis. We want to provide a ground truth, which creates reliable, annotated data sets that serve as the foundation for model training and validation, as well as enhancing NLP performance, which boosts the accuracy and effectiveness of the natural language processing models through quality annotations, and understanding context and sentiment, ensuring models grasp nuances like context, sentiment, and entities for more human-like comprehension. We also have the transferring of knowledge, which leverages the annotator's expertise and insights to enrich model training and improve decision-making. The quality of training data matters. Remember, the performance of resulting models hinges on the quality of the training data used. Of course, the role of annotation tools is systemic annotation. We want to streamline the annotation process for a more organized and efficient workflow. We want to have collaborative projects. We want to enable teams to work together on annotation tasks, enhancing the productivity and shared insights. We have, of course, standardization and consistency to maintain uniformity across annotations to ensure reliability and quality in the data. We also have quality control and review to implement robust review features that monitor and enhance the accuracy of annotations. And of course, automation and AI assistance. We want to be leveraging the AI tools that are available to speed up the annotation process and then reduce the manual effort. So why did we make this? What is the reason that we did this? We wanted to build a tool that was great for productivity, that had a user-friendly interface to ensure the platform is intuitive and easy to learn, right? We want to minimize the learning curve there. We wanted to have keyboard shortcuts to speed up tasks and reduce the number of clicks and eye movements required, as well as seamless document navigation to facilitate automatic transitions between documents for a smoother annotation experience. We want teamwork. Of course, we want to support projects with role-based permissions to enhance teamwork and streamline the process. We want to have customizable workflows for validation, review, and training that fit your project needs. And we wanted to have versioning and audit trails to maintain clear records of changes and decisions for accountability and easy tracking. We also, of course, want to make sure that we're improving over time. So we introduce new features regularly, right? Fostering an environment of ongoing enhancements, which I will be demonstrating at the end of some of our newest releases. We'll be learning from actions, so we refine the system based on annotator interactions, as well as the feedback of our customers. We have closed loop automations to implement a cycle of pre-training, annotating, retraining, and measuring for continuous model enhancement. The last step of our introduction here is the project creation workflow, which I'm just going to go over a little bit. Before we start, there is in fact a step 0. Where we figure out what type of project we want. We start thinking about our project pipeline and choosing our models and prompts, and that's where we'll be starting. But after that, it's very straightforward. You choose your project type and you follow our creation wizard. You'll select your model, define the rules, create the prompts, using our user-friendly menu editor to tailor the view for your annotators. To get started, you just click on the new project page after logging in. Here, you name your project, write a description, select your team of annotators. Then you follow our steps. Is that once you've reviewed that, you'll start uploading your tasks. And you can upload your tasks from your local machine or cloud services like AWS and Azure. And you can even pre-annotate them with your rules to give your agents a helpful head start. Once your annotators review the data set, You can choose to test your models and train them on the refined data set. Finally, you can export your models, tasks, pipelines for use in future projects. It's that easy. So let's get started. We're going to start with models, rules, and designing prompts. We have a variety of resources that are available in the project itself. And so the whole purpose of the product is to support every step in the development of your projects. To that end, we have access to resources for each part of the pipeline, your models, rules, and prompts. We're going to go through individually and define in greater detail all three of these together, and all three of these will act in your pre-annotation server. The really great thing about our hub of resources is that even though we have online resources available, there's a private repository for all of your models, rules, and prompts so that everything can stay in-house. The first thing we're going to talk about is your model. So just before you even start, we have a variety of models that are available online with a basic license. So from here, just navigate into the Online Models Hub. And you can see from here, we have filters such as named entity recognition, which is what we're going to be choosing today. And we can also filter through open source models, healthcare, finance, legal, or visual. Here I'm going to choose healthcare today because that's what everybody is working with here. So once you've selected your filters, you have the option to search. And you can, so for instance, you could search menopause and this would detect menopause specific entities. And only these ones would come up. Of course, there are times when you're going to have multiple entities to choose from. The way that you can choose is by looking at the benchmark data that's available here. So here you have every entity that is available through this specific model, and you can see the F1 score. We'll want to find a model that has at least some of the entities that we'll be looking to annotate so that we have less work to do. So having a look at this benchmark data, just to go briefly over them, we have the F1 score, which is the harmonic of precision and recall. It provides a single metric to evaluate the model's performance on imbalanced data sets. It ranges from 0 to 1, with 1 being perfect precision and recall. It's particularly useful when you need a balance between false positives and false negatives, which are these next two here. Of course, a false negative occurs when a model incorrectly predicts a negative class for an instance that is actually positive. And a false positive occurs when a model incorrectly predicts a positive class for an instance that is actually negative. So the next thing we have is precision, and precision measures the accuracy of positive predictions made by the model. Then we have, so a high precision model indicates that the most predicted positives are indeed true positives, making it crucial for applications where false positives are costly. Then we have the recall, and the recall measures the model's ability to identify all relevant instances. And then we have TP, which is our true positive. At the end, but I did actually skip by the total. So in this context, total often refers to the total number of instances in a data set, which includes true positive, false positives, true negatives, and false negatives. It provides a complete view of the data set size for calculating various metrics. And then lastly, we have, of course, our true positive. A true positive is when the model correctly predicts a positive class for an instance that is indeed positive. Once you've chosen your model, you can just go ahead and download it. So in this case, I would re-download this one I've already downloaded, or download one that I haven't downloaded before. Once you've downloaded a model, you'll find that it's available here in the local models. Here you also have the ability to upload other models that are based on the Spark NLP library. So these models are only available to your team. They'll not be put on the online model hub page. You're able to see the amount of storage you have available for models as well by clicking here. Next, we have our rules. So a rule in NLP and NER is a predefined condition or pattern used to identify and classify entities. It can be implemented as regular expressions or logical conditions. When applied alongside an NER model, rules serve as an alternate layer that refines the model's output. After the NER model makes predictions, the rules evaluate the results based on additional criteria. For example, a rule might specify that Dr. Smith should be followed by MD to be recognized as a valid entry. If the context is missing, the rule can filter out incorrect predictions. This approach enhances precision by incorporating domain-specific knowledge and resolving ambiguities, ensuring more accurate entity recognition while leveraging the scalability of NER models. Of course, we have rules here, and we have two main ways that we handle them within GenAI Lab. Users can provide a regex, a regular expression, that'll be used to label all possible hit chunks and label them as the target entity. For example, the labeling height entity will use the following regex provided here, is that all hits found in the text context that match the regex are pre-annotated as height. This is really useful if you have a programmatic rule that you want to define. The next, we have dictionary rules, which is what you will find here as well in medicine, is that you can see that we've chosen the entity name as medicine, and we've uploaded a CSV containing all of the medicines that we want to look for. So acetaminophen, acyclovir, etc. are all defined here. You can decide if there's a length, or maybe there's some prefixes or suffixes that help to define what a medicine is that you want to be included or not included. Prompts are another really interesting feature that we have available. And so a zero-shot prompt is an instruction given to the model that asks it to perform a task without prior examples or training, right? So you're not uploading a CSV the same way that you were. In fact, there's no prior examples needed. It relies on the model's ability to generalize from the training data. It's a really great text classification is really great asking a model to label a text as positive or negative without any necessary examples. So you can see here that we have prompts that are available here. And so in order to create one, you'll create a name. You'll decide if it's entity or relation. You'll have a description of what it is, and then you'll add your questions. Here we can see a symptom, right? And you can see the list of questions that are available. If you'd like to play around on this without adding it to a real project, we also have a playground that's available. And in order to access that, you just need to click on Playground. In the interest of time, I am going to leave that out. So all of these together are the resources that you'll be using when you create your project. So you have your models, your rules, and your prompts, and they're all available together on the project page. They're all saved separately so that you can continue to use them again and again in your projects, and you won't need to define them for every new project. The last thing I want to touch on is clusters. So Generative iLab uses the ability to view the list of all active servers, and any user can access the clusters page by navigating to settings and to clusters. The page provides, of course, here it is, provides the following details. You'll find the server name. It helps identify it while running pre-annotation or importing files, the license used, and its scope. So for instance, you'll see this air gap license has specific scopes for legal, finance, OCR, healthcare. The usage, so for instance, if this is a pre-annotation server or an OCR server or a test server or a training server, this information might be useful if you want to contact the user who deployed a server before deleting it, and you'll be able to see who it was deployed by and when. All of these use up resources in your project, and so if you're experiencing it going slower, for instance, or there are any errors, you'll be able to view the status here in the server logs. These are really helpful for trouble reshooting. You also have the option to toggle on auto refresh. Perfect. And so that ends my brief introduction into what you need to have before you start creating a project. Next, I am going to hand it over to Andre, who is going to talk about setting up your project.
Okay, thank you, Jessica. A very nice introduction. First of all, I'm pleased to see that in the audience we have some members of some projects and of some companies that we work with, and they are now more interested in this product, which is very nice to see. I would like to say hello to everyone in the audience. And right now I will try to share my screen. Yes. Okay. Okay, so when you open the GenAI lab, you will be prompted with this screen. You already saw it in Jessica's presentation. And the way we create a new project, we have this button here with a plus sign and says new, but we can also import them from an S3 bucket, as Jessica said, or from an Azure blob. Okay, let's create a project step by step by using our interface. First of all, you will have to select the title for your project. Let's add test now. On the second menu, you can show how your task will be served to the annotators. They can be served randomly or sequentially. You can have a description for the annotators or supervisors that are going to be the stakeholders for this project. And you can have some instructions. They can be short guidelines or a link to the guidelines that you developed, and we will talk about the guidelines later. You can toggle on task title editing. Sometimes that's useful. Some of our clients tried to edit the tasks by adding some information to them, but that can be done easily now with a different feature. I will show you at that point. When you create a project, you will be asked if your project is having a purpose of de-identification and how would you like to de-identify the data in your project. But we will create a simple NER text and assertion project for now, and we will go through the steps that we have for now. Let's add the test 2024 and see if this name is available now. Okay. Now this screen allows you to add users in different roles. The roles that we have are managers, reviewers, and annotators. I think all of your users should be included in your server that you get to test for the next 2 weeks. But for this example, I will add, for example, Dia. I'm prompted with all the accounts that Dia has on our machine. And let's select her important one. And now we can add her as an annotator, reviewer, or manager, or she can be all of them at once. And I'm adding her to the team. once I edit her, I get a list of the annotators that are, or the users that are added. This list can be later on edited, and during your project, when you see some of your annotators are doing better or worse, you can update their role. For example, I can make the user become a reviewer, or I can just change it to annotator, and this will give different privileges on the data set that she can see or review. And I can also make her a manager. Okay, moving to the next page. I am actually prompted with beginning to define and configure my project. I am going to go through 5 steps here. The first step is the content type. Then we define where to annotate. We define what resources we can use, how we customize our labels to make it more user interactive for special domain experts. And we have some advanced config at the end. The content type for GenAI can be video classifiers. For audio, we have emotion segmentation and audio classification. We also have HTML NER tagging. For image, we have visual NER labeling and visual NLP classification. Image classification, we can define a project as being text and name entity recognition and name entity recognition with assertion. For this purpose of exercising, let's choose name entity recognition with assertion. Yes. First of all, in the right side, I am prompted with a preview window where I can see the preliminary taxonomy. I can see a preview task and how does it look for now. This can be edited on the next step. I'm saving the config for now. And now we are moving on to step 2, where we define where to annotate. Here, we can choose to annotate entire documents, or we have a new feature that allows us to annotate only relevant sections that can be split by paragraph, by sentence, but let's stick to the entire document for now. We are reaching the page where we can choose from the models that we already have trained, as Jessica presented earlier. We can, for example, select any type of model here. We are being presented with the taxonomy that this model has. We can choose some rules that are set up, as Jessica shown you. From these rules, I can choose which ones I want to add to this project, or which ones I want to remove from the project. And I can also use some prompts that are pre-made. So these prompts can identify ages, can identify diseases, and so on. So it makes it easier for us to annotate and pre-annotate documents, actually. Okay. Once we decided what model to use, we click on next, and we are being prompted with an exercise taxonomy, right? And we are given the option to edit the tags, to remove tags, to move them around. The interrupted line here represents the fact that this label in the taxonomy is actually an assertion label. An assertion is actually providing contextual information related to a specific chunk or sentence when we annotate. When editing the labels that I want, for example, let's change date to age. Make sure you use colors that are intuitive. Colors are important when annotating, especially on large data sets. It makes it easier for annotators to identify them. It improves annotation speed. And when reviewing at certain point during your project, you get used to those colors. So from an annotation point of view, from our side, this is important. So let's choose red for age related. We can choose what model to pre-annotate age with, the prompt, or any rule that I would like to add. And if I toggle this on, age is becoming an assertion label. Okay. This is the friendly way of adding, a user-friendly way of adding labels, but there is also a code option where You can set up also, for example, hotkeys for your labels. We will simply add hotkey here. But I'm getting an error from the model that's not being deployed. So hotkeys can be customized for each one of your labels and makes it easier and faster for annotations. Okay. Let's hope this will allow me to move on with the project, with the next step. Let's start from the beginning. Okay, let's save here. The last step, step number 5, is actually an advanced configuration for a more user-friendly experience and annotating faster, or giving you a more friendly experience as an annotator or as a reviewer. It gives information related to serving tasks after completion submission. It makes it easier for the annotators, and all of these have come up after a lot of feedback from our hardware workers. Okay, we are saving our config. Everything is saved now. The next step would be to go to the tasks and import a task. Let's import one task. For example, we can add it from cloud, we can import it locally, we can generate synthetic tasks if it's the case. We can generate some augmented data, but that's Jessica's topic later on. For this purpose, let's add a sample task here. And now I'm added a sample task in the project. The way I annotate, I see the hotkey number 1 here. I press the letter 1 or the 1 on my keyboard, and I'm trying to look for a date. There is no date in this text. Person, let's annotate patient as person. And the way to annotate is to actually press the hotkey or press the button in the taxonomy bar here. And afterwards, double click the text we want to annotate, or just hover over with the mouse. And that way, this becomes an NER annotation. The way we add assertions, for example, for the person patient, we actually have 5 assertions labels here: present, past, patient, family, and someone else. And let's say this patient is presenting today, and that makes it present tense, and I'm actually doing a double layer annotation. And this is the way we apply assertions to our NER labels, and that's a way to add contextual information related to this entire sentence, that the patient is present at that time, and the assertion is indicating that. 2 hours prior can be time, and that means it happened in the past, and I'm adding a past assertion. Okay, this is the basic way of doing annotations. The annotated chunks can be easily deleted with backspace or by pressing the delete button here. Every hotkey we have usually are represented on the right upper corner of the visual representation of that button. Okay, let's see what we have on the right hand side. This is the place where we can change roles. You saw at the beginning, when I create a project, I'm given manager, reviewer, and annotator role. Right now I'm a manager, but I can change it to reviewer or annotator from here. This is where I see what I annotated. You see the label time. You see I can even add some meta information here. I can add key or value for this specific label. And I can also relate it to, for example, another label, but I will give you more examples later on. Another thing I have here is versions. Under versions, I can see who created the completion. I can see how much time it took for me to actually work on this completion. And I can see if this is marked as ground truth. I can also delete this completion, or I can duplicate it and work on a new one. And this way I have two different completions. Maybe on the newest one, I want to do some changes, and the previous changes, I want to show them to some colleagues or discuss them later, but I'm also doing some changes. At the end of my annotations, I simply mark it as ground truth, the completion that I want the model to be trained with and that I consider correct. And I press submit, and the task is now submitted. Okay, that concludes the way of creating a project and annotating a simple sample document. Other things that can be done in this window is actually having some settings set up for making annotations easier for you. You can have this option, for example, where we trim spaces and punctuation marks, makes it easier for model training. If this is turned on, when I'm trying to annotate, for example, Accutane, the final punctuation mark is left out. But this is, if this is turned off, for example, the punctuation marks are also taken with the word and creates an entire chunk. So those are some settings that you can play with here. You can also enable your hotkeys to be shown. You can show some confidence of pre-annotations inside the regions. This is one confidence because it's actually ground truth. I created this annotation right now. This is not pre-annotated. I can also have line numbers in text. When I present to someone or when we discuss, we can direct someone to that line number, for example. And so on. Okay. This pretty much is the project creation and how to get started with annotating files. I will discuss more about the features that we have when I present you the analytics page and how to compare some annotations between annotators. Okay. Jessica?
All right, thank you so much.
Thank you.
I'm going to go ahead and share my screen again. So now that we've covered just the basics of project creation and creating an annotation, and annotating a document, I am just going to go over what it takes to deploy a pre-annotation server. Let me go ahead and share my screen again. Perfect. All right, so you can see here that I am just in a sample project, and they are still incomplete, but the pre-annotation has been run. Now, we have the option to hit pre-annotate, and this is going to automatically bring us to this existing server. We could choose to create a new server, which is what we're going to do momentarily, but you can see here that all of these are ready. The reason that this one here is that because we've already clicked on it, this is why it will be set as Summit Demo, which is the name of the project here. So say for instance, I go to a new project. This is the Summit Demo that has been trained and tested. And because based on the model's rules and pipelines in this project have not been specifically done, we can go ahead and just click create a server. And that is going to create a server with, as mentioned, all of the model's rules, pipelines that will be done. And then this does take a moment to happen. So if I were to go here, perfect. And you can see that this is busy. I can't choose it yet. Is that once it's available, it would be able, I would be able to choose it. So you can see here, when you click on each of the existing servers, you can see all of the models that have been deployed on it, as well as the embeddings that are used. Of course, embeddings clinical being our preferred one at the moment. You also have the option to choose whether or not you're doing it on all non-pre-annotated tasks. So this is really useful if you've uploaded a bunch of new data that you want to use, that you want to apply the same server that you've done in the past. You can do all incomplete tasks, which is tasks that haven't been reviewed by a human. So for instance, if you've updated your model, you might want to might want to redeploy. That way that you're using the most updated version of the model. Or you can just do all tasks. Is that this is great to start with, of course, or it's also great if you've trained your model again and you want the most updated version, but you haven't gone ahead and started your annotations yet. So once you've chosen all of that, all you really have to do is hit start and it'll apply itself. And then of course the magic that we've seen earlier, where it'll go ahead. And of course the pre-annotation here is complete. And then you can go ahead and see. And so once you've set up your project properly, it really is that easy to deploy a pre-annotation server. So we've wrapped up a little bit early on this time. That said, right now we have a scheduled break. And so I am going to leave you to be free for another 15 minutes and we'll reconvene again at 10 o'clock. Is that where Andre will start again with the annotation guidelines. So thank you everybody so much. And I will see you guys soon.
Okay. Okay. Related to the guidelines, which is a book for annotators, the book of rules, the book of definitions, the book of setting things and defining how we actually do the annotations, and where we solve our discrepancies afterwards and have our final decisions related to certain labels. We will discuss who are the stakeholders and roles for the guidelines, what's the structure and the content of the guidelines, what are some best practices for defining good guidelines. I will show you some annotation errors, and at the end we will run through the analytics page we have from Generative AI Lab. And in the analytics page, I want to show you a project that has a high inter-annotator agreement and a project that has a low inter-annotator agreement. The basis of having a high inter-annotator agreement are the guidelines. And if the guidelines are not designed properly, the annotations will have a model that's not going to perform optimally, and your F1 scores and all of the outcomes of that model will not do well. And for that purpose, this book, the guidelines, will keep track of all the decisions are made for certain entities and ways to annotate different encounters of problems or diseases or tests. And when you have even two minds deciding on how to annotate a chunk, there will be discrepancies that you cannot think of right now. But when you put two medical doctors together and you have discrepancies, those should be sorted out and written in the so-called guidelines. Okay, let's see about the stakeholder and roles. First of all, when you start on an NER project, the first thing to do is to have an annotator lead and assign someone as the annotator lead. He or she will be the person that oversees the entire project, will make sure that the guidelines are updated and align with the project objective. There will be a change log of which the annotator lead is responsible to keep track of changes. And usually the annotator lead has the manager role in all projects. Then you have the annotators. The annotators in healthcare projects are usually medical doctors or nurses or similar specialists. They assess data, they curate data, and they annotate data. They have usually the role in the projects as a reviewer or an annotator. If possible, there should be someone with a more technical view of things. Usually we have data scientists, at least one data scientist assigned to a team of annotators. In the current projects that we have, we usually keep 2, 3, maximum 4 annotators and 1 data scientist. The 4 annotators will deal with issues and discrepancies related to actual subject problems, to healthcare problems, and the data scientists will make sure that the annotations and the way of annotating data will actually lead the project to its final aim. And as I said, the data scientists will provide requirements for granularity, specificity. Other stakeholders are the, let's say, call them now quality assurance people or the reviewers. They ensure that the guidelines are of quality and they are consistent with the annotations. Usually a reviewer or a quality assurance person is actually an annotator that is more experienced or has dealt with more projects in the past. The structure and content of the guidelines. For this training, I prepared a sample guidelines for you that will be sent over. Based on this guideline, I will show you how I create a project. Once again, we will go through the step one once again and show you why guidelines are important and why should you develop the guidelines before starting your project. The guidelines will start with a cover page having a title and the purpose of that project. It looks like a book. I told you, you should have the content. It usually comprises of your entity labels, your assertion labels, your relations, if your models are planned to have relations, and also text classification. This is the basic structure of the guidelines we use. The introduction should usually take care of the fact that you might bring other people to the project at certain times during its course, and the people you bring should have a first clear glance on how the project is trying to aim something or what are the clear goals of that project. So for that reason, the introduction should be well written and, let's say, accommodate the newcomer to the project. The next page should be your taxonomy that you define inside NLP in GenAI lab. The NER labels should be marked with green. The extractions of any of the chunks that you want to highlight or extract should be marked with green, and you also should highlight your incorrect way of extracting certain chunks. In our sample, they are marked with gray. So for example, here you have the entity age. You see we have a definition. We have some extraction rules that are already decided upon. We see what kind of assertions we can assign. For the age, there are none. And for also relations, what type of relation age can have. The assertion labels, as I told you, are used to indicate the context inside a sentence or indicate an attribute of an entity. And I told you that an assertion is actually placed on top of an NER label. Exemplified here, we have the present and absent assertions. Usually the most common used. The absent assertion is actually added to negated entities. And you see an example on point A for absent assertion, where the ultrasound showed that the patient does not have psoriasis. And you see the main entity, the NER entity is disease syndrome disorder. And the assertion assigned to it is actually absent because the negation does not have is indicating that. On the right side, you see a table, and we keep this table for assertions. The table will actually show me where can I apply, for example, a certain assertion. In this project and this example that we will get, the assertions will be only placed for disease syndrome disorder. And that's one way we can configure it in the GenAI lab also. Relations are used to link two entities to one another. Usually the relations will show causality. It will show results of certain medical tests or lab tests. We use relations to identify dates. I don't know, treatment dates, treatment starting dates, or treatment end dates. They are important in some cases. And the relations are a different way of linking, as I said, two entities together. Once again, we have a relation table on the right side. For example, you see on the upper part of the table entity 1 and entity 2. This demonstrates that disease syndrome disorder will be related to date. And it says here label needed. I will show you in an example what label means. The label of a relation is actually the name of that relation. And direction needed, in this case, we don't need the direction, because usually direction of a relation indicates causality. And for this kind of a relation, I am not interested in causality because this is a time entity and this is a disease entity. What I'm interested in causality is for diseases or for certain symptoms. We don't have a symptoms entity for this sample, but if I had a symptom entity, I'm interested if that symptom is the cause of that disease, or is one disease the cause of another, for example, obesity and diabetes. So for that reason, we need a direction of a relation. I will show you also what a direction of a relation is in a clear example. And for the tests, we use most of the time the relation is result of, and that indicates that the entity 2, which is called test result, is related to vital sign finding, and we have a relation between those two. Once again, direction is not needed because we know already that the test result is of that vital sign. Those are relations. Text classification can be also added. Those are some checkboxes that allows classifying relevant sections of entire documents based on sentiment or based on gender or on the age of patient grouping. You actually can create cohort of patients using classification and many other use cases for this. The end of your guideline should be the change log. The change log should be updated on every iterative process you have. The guideline will have several changes during the course of your project. We ended up for example, the last project we had version 7. So we have meetings once 2 or 3 days. On those meetings, we discuss our discrepancies and why certain things should be extracted one way or another. And what we change on that meeting, on that iterative meeting, we actually add to the change log, and we have one annotator that's responsible of updating the change log. Okay, one example from the guideline is the age entity. You see on the definition, we should extract all mentions of ages in a document, past or present, that are related to the patient or with anybody else. So when you start annotating, you might think, okay, I need to extract ages, but do I include other people that are mentioned in the medical file? Maybe there is someone from the family that's mentioned with the age. Should I include that? So that is in the definition already. It's related to the patient or with anybody else. The extraction rules. Numbers should be extracted along with expressions such as years old or age of. NLP models have been struggling with providing, let's say, robust models that only have tokens with numbers. For that reason, when we usually extract numbers, we try to add proximity tokens like year old or letters around the tokens that only have numbers. So that way the model will learn easier that when an age is detected for presentation purposes, for example, we'll have tokens with text around it. So this rule is added in extraction rules. So you don't extract. You see, we have an example with green. That's the correct examples where we include the token year and old. And in the example B, we include the token S or the letter S. Examples C and D are wrong because years and old are not extracted. It's only the numbers that are extracted. Okay. Employment. In many models, the employment status is important, and you see the definition. Mentions of jobs or occupations included in the text. So that means we are interested in actual positions that someone has or the patient has, and we go further, extract terms that are related to any specific jobs or employment, whether related to the patient or not. So we also extract employments of workers, but we do not extract words such as works, working, or employed. So we are not interested in the employment status. We are actually interested in the jobs or occupation per se. We don't have an assertion for this label, and we don't have relations. For your exercises, I will send you over these guidelines, and I will also set up a project so you can play with. Okay, one more example for disease syndrome disorder. Some bad ways of extracting it or defining this entity, which is common, and some good ways of doing it, which will improve your robustness of your model's robustness. Because as you can see, the definition is extract all diseases, syndromes, and any relevant condition mentioned in the document. Now, when you extract, for example, you see example C here, chronic kidney disease. You tend to extract the word chronic also with kidney disease, but that can be also done as defining a modifier label for words such as chronic, recurrent, acute, and having a more granular model where you extract kidney disease as disease syndrome disorder and chronic is used as a modifier. And you just relate those two entities using relations that I've shown you previously. Okay, once again, examples to extract are with green and what to avoid are with gray. Let's see some best practices in developing guidelines. I've somehow covered them already, but your guidelines should be in one single document. You should not have multiple documents, even when the version changes, when you meet together and decide on certain things. The guideline should be kept in the same document, but keep a change log in that document. You saw the definitions before. They are specific, they are straightforward, and no ambiguity can be interpreted from the definitions or extraction rules. The objectives of your guidelines should be clear stated in the introduction, so that I don't know, supervisors, stakeholders can understand what's going on in that project. There should be consistency. So there might be labels, for example, treatment and drugs. Those two can be in a contradiction if you talk to different two doctors. So there should be a consistency in deciding what to extract as treatment and what should you extract as drugs. To have a robust model, you have to cross-check annotations. You need to use multiple annotators for the same data set. That means, let's say you have 3 documents, you assign those 3 documents to the same 3 annotators, and you define such thing called as a seed corpora in our projects, where we try to see how is that medical professional thinking of extracting certain things. We meet after annotating the 3 documents. We decide what's the best way in terms of building a model, what's the best way of extracting that chunk or I don't know, token. And that way we ensure the inter-annotator agreement stays good. And of course, for every type of rule or description you have for your entities, you have to be explicit and you have to write them down, even if they are in detail. You will see in the sample guidelines some examples like that. Once again, the goals should be defined clearly. You should define what do you need to extract from text, what's the main purpose of that project. Is the main purpose NER and the secondary purpose is text classification, or is the other way around? Usually, combining those two will take much longer than just creating 2 projects separately for classification and NER, but that's not a general rule. Communication between your members is key. What to avoid in annotation projects is private communication between annotators. So if they privately talk to each other and have decisions, let's say you have 3 annotators, 2 of them talk to each other and take a decision on extracting certain things one way, the other annotator will not be in line with those, and the inter-annotator agreement will go down. I told you already that you should keep track in a changelog of the changes that you do. The annotation guidelines, the first version of your guidelines should be tested. I will show you in our example how we test it with the seed corpus. And the seed corpus is a pilot annotation. We usually have about 2 or 3 seed corpuses annotations where, as I told you, they will annotate something in common and we see what are the mistakes they do. And I will show you how we identify those mistakes. And of course, dealing with those mistakes will make your model better. I will show you some best practices, very short, on NER extractions. And as I said, first of all, when you start, you should define the granularity of your taxonomy. In the left side here, you can see that persistent coughing, of course, can be extracted as clinical problem, but persistent coughing can also be extracted as modifier and symptom and can have a relation between them. And this way, your model is better. You have a more robust model this way, if you decide to have it granular. Of course, this is not wrong, but your model will be more general. On the right side, we see that both of these are treatment, right? But deciding where the boundary between a drug and actually treatment is actually important. So this should be decided in the guidelines. On the sample documents you have it, and this deciding that will avoid discrepancies and will avoid overlapping of certain entities. Okay, more ways on going more granular with your project. This is how a relation looks between two entities, and usually extractions of chunks should not include more than 2, 3, 4 words maximum. The more words you will have, the more the harder will be for the model to have good results. So for that reason, if you see a lot of extractions with 3, 4 words, you should consider splitting the entities, like I've shown you here in this example. We created an entity for metastasis, we created an entity for site, and then we related those two, because this way the model will not learn. There are too many tokens in this chunk. Okay. One way to, as I said, increase, or another way to increase your model performance, robustness, is to combine the features that GenAI Lab has, to combine assertions, relations, and text classification. You see here that the word potential makes the respiratory issue actually having an assertion of possible, and the model is going to learn from this context that it is not actually a diagnosis of respiratory issue. It is only possible that the patient has such thing. The assertion taxonomy that you have should be simple. Usually in our projects, the present assertion is by default, and we only have absent assertions, hypothetical. The present one, we consider it as being the default assertion label. If you, for example, I have this example here, no family history of cancer. You could have the assertion family, you could have the assertion absent for cancer, you could have the assertion past for cancer. So those are already 3 assertions that you can attribute to cancer. And for situations like this, which are rare and but are important, we have an order of assertions that we keep. So what assertion would be more important for us here? Maybe family, because this is talking about family and not about the patient per se, and that means family should be prioritized as an assertion for this token here. For example, if you cannot decide if you want to extract a drug as an allergen or as a drug ingredient or drug, you can also create the assertion allergen, and that way you have both. And from the token and proximity allergy, the model will learn that penicillin is actually an allergen. Okay. Relations. This I described already in my presentation, but direction of a relation is actually the direction of the arrow that you see going. So we have here psoriasis, and later on with psoriatic arthritis. That means the patient had psoriasis and later on developed arthritis because this was the first disease, and we have causality arrow here to psoriatic arthritis. Let's see some frequent annotation errors. For example, there is the human accidental error where, for example, gender is extracted as age. This is usually due to the hotkeys that annotators have. There are wrong extractions because if you annotate for 3, 4, 5, 6 hours straight in a day, you just look at medical documents, you might, I don't know, select a label which is not correct, and there is the normal disagreement, and this will be checked with analytics, and I will show you how we do that. Missing extractions are also frequent. Wrong labels, as I said, gender is assigned to an age entity, or wrong granularity. See here, the age is extracted only with the token that includes numbers, and wrong extractions, as I told you, are common. Now, the way of identifying those mistakes can be done manually inside NLP Lab. It's more visual friendly. It's a design for small reviews and for the reviewer, let's say, and I will show you how to do that. And we have CSV way of doing reviews, and I will show you how we do that also. Okay, let me switch to a project that I prepared for you. Now, this is a project and an example in which you will see a low inter-annotator agreement in the analytics. In the navigation bar here, we go to analytics. On the first page here, I have 3 tabs. I have a tab related to tasks, I have a tab related to team productivity, and I have a tab related to inter-annotator agreement. Everything here can be updated in real time with this refresh button. And I can see in real time who did what. I can see how many tasks we have, how many tasks we did in the last 30 days, what's the status of that task. With red, we have incomplete, with yellow, we have in progress, and about 20% of the tasks are submitted. I can see who created the tasks. I see the user Akar here created 40% of the tasks and user Korkmaz about 65%. And the next tab is actually showing me who did and how many completions each annotator did. We have the annotator Alexei who did 30 completions, annotator J did 10 completions. I can also have a tab here that shows me how many completions are reviewed and how many are in progress. I think it's exemplified here. You see 4 of the tasks are reviewed, 2 are still in progress, about 200 are annotated. Okay. The next tab shows me the average length of the task. I see that the annotator J has more lengthy tasks, let's say. Annotator Korkmaz also, that means it will take longer for J to annotate, so I will wait for him. So what I want to show you is that this tab, the tasks tab in the analytics, is actually teaching me how to manage my team properly. So this is more for the manager of that project or for the supervisor. And also teaches me what are the labels that will require more synthetic data generation, maybe the ones that are the entities that are not that frequent. Maybe I am having in mind in creating some synthetically data to help the model with those labels that are performing not that good. Good. The next one is total label frequency across completion. I can see that drinking environment has only 1 count here, and I can see that other diseases is annotated about 700 times. This means the labels that are annotated a lot do not require more attention. We have enough count of those labels, and the model will learn from those. The labels that we are interested in are those with low counts, right? The drinking environment, the drinking cessation attempt, cessation treatment, those are the labels that require some synthetic data generation maybe, or when selecting the data set, we should have in mind that maybe with a keyword search, we should use, add those documents. Average label frequency per completion. So for each completion of a document, how many times was a label present there? For example, in a document, in average, cardiovascular diseases was present 4 times. But once again, drinking environment was not that present in documents, and those that have low counts here should be looked into, right? And decided. Do we create synthetic data? Do we add another data set that might have this, or we drop them? our data set does not comprise of these labels. There's nothing we can do. We just drop these labels entities that we decided are important for us at first. Now, label frequency per annotator. On the right side here, I can select the annotator and I can see what the annotator extracted and how many times. They usually are consistent, but it depends on the spread and the assignment of the documents for that specific annotator. The robustness of your model is also defined by the total and distinct values you have across your completions. With blue here, it are the distinct values of the specific entity. For smoking status here, we have 22 extractions that are different from one another, and we have 112 total extractions of smoking status. So there are 22 ways of describing that a patient is smoking, right? That's what I get from here. And that means the higher this is, the harder will be for the model to learn, right? There are too many ways describing how a patient is smoking. Okay. Now we reach the length of extractions, the average number of tokens we have for each label. Tokens means words. So if I have more than 3, you see our annotators are already trained to extract as few as possible. The maximum is for drinking environment, which has 3 tokens inside, but all of those others are under 3 tokens. That means the model is going to learn from this. This is a good way of extracting. Anyway, the annotators that I've shown in this example are experienced ones, and they already know almost all the rules. But what I want to exemplify, even with experienced annotators, the inter-annotator agreement can be bad because the project is complex. You see how many entities we have. They can be subject to interpretation, and that for that reason, the guidelines are very, very important. Okay, another tab we have, I told you, numeric values are hard for NLP models, and numeric values across labels are exemplified here. For substance frequency, of course, we'll expect to have numeric values, and for substance quantity also. So this is also important when assessing your project. Okay, now. The second tab we have in the analytics is team productivity. And under team productivity, we can see the total completions the project has, the completions by status. Staired completions means the ground truth completions, and we can also look on them by time period. More information on how many tasks are with ground truth and how many are actually resubmitted completions, right? The annotator went back to that document and did some changes and resubmitted it. So we have ground truth completions 22 and total completions 30. The difference, the 8 completions between it's that the annotator Korkmaz went back 8 times and did 8 different other completions. I can follow the completions over time. I can calculate some productivity for certain annotators. I can see what are the days when they are available to work more. Our healthcare professionals usually work more over the weekends. They are clinicians and also deal with patients. So we expect them to work more of the weekend, but some of them work in the afternoon. So planning your project, this is a very nice graph to have. You saw in the first tab that the annotator J is having lengthier tasks, and we can also see that he spent more time in annotating compared to the other annotators. This means we should see why did he spend more time, but we know already the tasks were longer, so it took more time to read them and do the annotators. When he went back to do some edits on his completions, he took about 2 minutes to do the edits. So he knew exactly what to look for. I will show you how he knew exactly in the next in our next step here, and how he identified the mistakes straight away. Okay, we see the average number of edits per task. We see the average number of tokens for resubmitted or for the reviewed tasks. So how many tokens were changed in that review that the annotator did, and the average number of reviews per tasks, the total number of tokens across submitted and reviewed tasks. So I once again can see how many changes the annotator did and what are the completions over time. And now we reach to one of the important parts of analytics, and that's the inter-annotator agreement. And here I want to exemplify an inter-annotator agreement that's not that good. This usually happens the first week we start a project, when we don't have decisions, when we have a lot of discrepancy, and where the minds are thinking differently for each annotator. And let's look at a bad IA example. I am selecting the annotator J compared to annotator Shala. And I see that there is an agreement of 37% between them, and there is a disagreement, a high disagreement. If I train a model like this, it's going to be very bad. Now we have to look why this disagreement happens. Let's look at the annotator Korkmaz. Okay, same discrepancy. J and Korkmaz is doing even worse, so this is not okay. Alexei and J, okay, all of them are in disagreement, and let's figure out why. Okay, Alexei and J. Now I am given and prompted with a visual representation on why are they in disagreement. They extracted cardiac symptoms, 38% in agreement, 60% in disagreement. So you see they disagree on many of the labels that we have. That means we have to review those. And let me show you how we do that. If we go down, we have the extraction comparison by chunks between the two annotators. And firstly, I'm being prompted with a visual way of seeing the agreement between this chunk, for example, vomiting. Alexei extracted it as gut symptoms, and Jay extracted it as other symptoms. And we get in a call and we discuss. Jay says, I decided to extract it because of that. Alexei decided to extract it because of that. And the lead annotator will take the decision, and that decision will be brought to the guidelines. And that's the decision that will be the way that it will be annotated later on. Now, this can be downloaded as a CSV, and let's do this right now. I am now importing it into Excel. Okay, what I have here, let's see. On column A, I have the chunks, right? The chunks extracted by annotators. On column B, I have annotator number 1. On column D, I have annotator number 2. Now, for this chunk, the first annotator named Alexei extracted it as other diseases. The second annotator, J, other symptoms. This is a false agreement between them. For the sake of doing this faster, I will just filter out the ones that are false, right? The disagreement between them. And let's look. Infarction, extracted by Alexei as cardiovascular diseases, missed by J. This is a clear miss. I mark it with red. J should go back to task number 25 and see why he missed infarction. And this is the way we do it for all the disagreements. It takes time, but this is the only way to build robust and strong models. The disagreements will be lesser after we have some discussions because this is decided upon. And I will show you how the project looked about 2 months later. But let me show you some other ways of reviewing until then. So this is one way with the CSV, filtering out with the false ones and looking at the extractions from each annotator. If I have a pre-annotation on this project, I can select the annotator here. We don't have pre-annotations for this project, but I can select the annotator and I can see how he did versus predictions, how the predictions did versus the annotator's ground truth, right? If I go down, I can see what chunks Alexei extracted. I can change the annotator, and me as a, for example, lead annotator, I am downloading the CSV from Shala, the annotator Shala, and I want to look what Shala extracted for cardiac symptoms, for example. Once again, I import this in a CSV, in an Excel, sorry. Import the CSV, all extracted chunks, comma delimitation, okay. Good. Now, for this chunk, the annotator assigned label absent because this is an assertion, but I am filtering out maybe the assertions and I'm left with only the NER entities. And I want to see, for example, for label cardiac symptoms. I filter out everything else. Those are the chunks. I should have the labels here. I think this is wrongly formatted, but cessation treatment, and I can see what did Shala extracted, what are the chunks that she extracted for cessation treatment. This is also an assertion that we had. And I can see that cessation treatment AA, that means maybe anonymous alcoholics, if I'm correct, in task ID 40 was extracted as cessation treatment. I agree with that, yes. Then I will mark this, her extraction, as green, right? If I don't like it, I will mark it as red. I send her the CSV. She will do the corrections according to the tasks they belong to. Okay, that's one way of looking at the extractions. This is the CSV way, and I will show you then afterwards the user-friendly way. The frequency of certain labels is important. Let me show you why. Usually, if a label has low frequency of extractions or encountering it in the files, that means the model is not going to learn from that extraction. What I'm not going to look into here is the labels that have high frequency. If the labels are high in frequency, the chunks are high in frequency and the labels, that means they're going to perform well. What I want to look is at the labels that are extracted only once or twice. And I am filtering out everything and I keep once or twice, right? This is only extracted once or twice. And if it's extracted once or twice and does not have regularity in a data set that should be heterogeneous, that means the annotator might make some mistakes, right? And this is one way of looking for mistakes. If it's one extraction only, might be, you see, inducible heart block. Inducible complete heart block might just have extracted only heart block here. Too many tokens and it's only one occurrence. It's not going to work well. Ischemic right foot. Right foot might have been extracted as anatomic part, right? left internal carotid artery stenosis, carotid artery stenosis, left as a side internal anatomic part, and do relation between them. This one extraction will mess up with my model results. This is one way of doing reviews. You just filter the ones that are extracted only once and have no repeated extractions. Those chunks should be verified. And this is what I do in the projects that I lead. I just go one by one and check what they do. Okay. And next, I can see the chunks extracted by each entity. For example, I'm interested in respiratory symptoms. And I can see that cough was extracted by Shalat twice, by Alexei twice, by Korkmaz once, and by J 0 times. If we have the same common documents, it should be the same, the extraction of cough, right? And it should be extracted as respiratory symptom. Then we discuss why this happened, and we take a decision. Now, this is the way of doing your analytics and your inter-annotator agreement inside GenAI Lab and with CSVs. But that can also be checked in a more user-friendly manner, not that thoroughly, let's say, but can be checked. But before I show you that, let me show you how a good IAA looks like. So the project, the smoking and alcohol project that we developed and published, the models, later on, after 3 months of iterative processes, what do we see? I dropped 2 annotators. We only kept 2 of them. I dropped 2 other annotators that we used only for the seed corpus. We wanted their mind, we wanted to annotate, we wanted them to contribute to the guidelines complexity, and afterwards we switched them to another project. So I was left with only 2 annotators, but let's look at the agreement between them, J and Shala. And right now I have a 94% agreement, which is almost perfect. If we reach 95, 98, that's perfect. But this is what you should aim for. And that's only achievable doing the processes that I've shown you iteratively. Okay. Now, how can you look at some discrepancies between the annotators more visually appealing? You see, the GenAI Lab tool is very intuitive in terms of managing everything here. You have tasks that are incomplete. You can sort by incomplete, by in progress tasks. But also what I have here is tags. And I can see that for calculating inter-annotator agreement, as I told you, we should assign the annotators some tasks in common. And that is something we do weekly, right? Or every 2 days. They will annotate 2 or 1 task in common, and we see if the annotations are still consistent between them. I am filtering out for the tasks that have the inter-annotator agreement tag. And I see I have a lot of those, right? I have about 2 pages, so 11 tasks. Let's look at one of it. Okay, I am presented with the taxonomy here. The ones that have lines interrupted are assertions visually. In the right side here, I have the regions that are extracted, right? And here I have versions. And under versions, me as a manager, the role is manager now. I can see what Jay did and what Shala did with this task. It seems that it took Shala 7 minutes and 45 seconds to annotate this document, which was maybe pre-annotated at that time already. And it took Jay 10 minutes. That means J is slightly slower, but we are not interested in time right now. We're not calculating productivity. We want to see what J did different compared to Shala and how it differs. I see that J created a new completion by pressing this button at one point, and he did 6 edits for this document. It took him 3 minutes and 34 seconds to do those 6 edits. And afterwards, he marked the document once again as being ground truth. But the previous completion is no longer a ground truth, right? But right now, I want to compare it to Shalah's and see if Shalah extracted something different here compared to J. And how do I do that? I press on the button here on View All Completions. And now I'm presented with parallel extractions for the 2 annotators. If there are 4 annotators, I can swipe laterally and I can see 4 completions. Now I select J's ground truth and I select Shalah's ground truth, right? And I press on Show Differences. And straight away, the assertion and entities that are with green are correct, but I have entities with red and they have a disagreement between them, which means the model at the end is not going to perform well. This is the way of doing the reviews more visually appearing, and you can see directly what's wrong or what's not wrong or what's okay. Otherwise, you can compare it like this. You just read everything and see what's extracted for what. And this is something we do in live reviews during our calls. Okay, that's pretty much what I wanted to show you related to analytics, related to inter-annotator agreement, and how we make sure that we have consistency in our team when developing models. Okay, Jessica?
Thank you so much for that. All right, the next thing that we're going to discuss today is model training, and I'm going to go ahead and start that off. If you'll give me just one moment, I will share my screen again. All right, so from your projects view, when you go into your project, on the left-hand menu, you'll want to find train. Now there's a lot of things to unpack here, so if you'll give me one moment. We'll get started. Perfect. So once your team of annotators has put through enough examples with the model to work from, you can go ahead and retrain your model on your data, which will be a minimum of 50 examples for each entity. And you'll be able to see that from the analytics, which Andre has just shown us. To start your training, you'll obviously head here to the training page. You'll have multiple options here for the training type. We have the NER, we have assertion and RE as well, since you can't pick all 3 models at the same time. So you'll train your classification model different from your assertion model and so forth. All of the entities that you have in your taxonomy will be included automatically. Then you need to select your license type. This affects the embeddings that are available. So you have your open source, healthcare, finance, and legal. Embeddings are very important because this is the way that the words are translated into a high-level numerical space. Their meaning is related to numbers. The best one currently for healthcare is Embeddings Clinical. Then you have the option to train from scratch. That is, you don't have to base your models on anything in order to improve it. Alternatively, the second option is to choose transfer learning. You'll have to pick one available model to start from. The entities in this model should have some sort of relation and coverage with respect to your taxonomy. It makes sense to use transfer learning when you already have a model that you've used for pre-annotation. You can include the base model labels when your base model contains more model labels than is currently used in your project. On the right side, you have the training parameters. For instance, your epochs on the right-hand side will change the weight of the model as a result of the new data. Each model is an adjustment of all the weights of your model according to your input data. The learning rate determines the size of the steps taken during the optimization process when updating the model's weights. A suitable learning rate helps the model coverage to a good solution without oscillating or diverging. Too high a learning rate can lead to instability, while too low a rate can result in slow convergence. Learning rate decay refers to the gradual reduction of the learning rate over time during training. It allows the model to make larger updates in the initial phases of training to quickly find a good region in the loss landscape, and smaller updates as training progresses to fine-tune the model. Step decay is a very common method. Dropout is a regularization technique that randomly sets a fraction of the neurons to 0 during training to prevent overfitting. By randomly dropping units, dropout helps the model generalize better to unseen data. The dropout rate, or the probability of dropping, typically ranges from 0.2 to 0.5, depending on the complexity of the model and the amount of training data available. The batch size refers to the number of training examples used in one iteration of model training. A smaller batch size can lead to a more accurate estimate on the gradient, but may take longer to train due to more frequent weight updates. Conversely, a larger batch size can speed up training, but may lead to poor generalization. Common batch sizes range from 16 to 256, depending on the available computational resources and the dataset size. We recommend that you use, unless otherwise needed, that you use these settings that we have set automatically. For instance, if you're training a model based on 100 tasks, you can use a pool of tasks, or you might choose to only use some of them to train the model and some to test. You can choose to share a snippet of the tests you use during training in case you want to publish your model later. You can also generate the confusion matrix, which will give you a good idea of the overlapping entities that may require better annotation guidelines, which you can see from the analytics page that Andre demonstrated as well. You can also filter based on additional tags, which allows you to only train a certain model on certain data. Of course, active learning will automatically be triggered on your model after a set number of completions. You can see if you'd like to create a custom script for your training, we have a template that's available here. And you can go ahead and see the code necessary to prepare the data set, define the training pipeline, and start training. From here, obviously, you would just upload your script from here based on your training type. We also have a training wizard, which will bring you more slowly throughout the steps. So we have NER, healthcare, glove, disable the transfer learning, and then this will bring us through for the epoch, the learning rate, the rate of decay, dropout, and batch. You'll be able to train and test your data with a random split. And you can generate a confusion matrix if you'd like, filtered by submitted completions. Active learning is a really interesting feature. This will trigger the training cluster after a certain amount of completions are done, and so then it won't need to be manually triggered after all. We recommend a minimum of 50 completion counts, but you can certainly set it higher as well. Turning this on will just mean that it happens automatically. From here, you just click and train your model. You're able to, once you've started training your model, you can stop, you can choose to run it in the background, and you can show the logs of how it's going. A new training server is created during the training, and the training pipeline is dynamically generated based on your configuration and the training options that you've selected. You can opt to deploy your model after training. If so, the newly trained model is deployed for pre-annotation in this step, and you can use it from the tasks page by selecting some tasks and clicking on the pre-annotation button. The training server is removed, and final checks are made on the annotation server in case the user opts for automatic deployment. And so this will continue, and this takes a significant, well, I wouldn't say a significant amount of time, but this does take some time. So you can see here if the training is in progress. If you were to navigate back to it. And because we have already reached our maximum amount of servers here, we're not able to test the previous configuration that I've set in. We could go and navigate to our clusters and see what is happening. And so we can see that there's 3 pre-annotation servers, and we have 1 training server, which is being deployed currently. We can have a look at the logs from here as well. And we can see that it's being applied on every piece of data that was available. I'm going to delete previous cluster so that I can go ahead and navigate back to where I was, have a look at the training. And so you can see here, I can, in the top right, I can click test configuration, and all models in the project configuration will be tested against ground truth completions from the task tagged as test. We can see now here that this training is nearly complete, and we can go ahead and see the logs of that as well, which will be the same logs as viewable from the cluster. And if we go and check our progress, I'm a little bit impatient, admittedly. A little too impatient, it seems. Now, I've already tested this once. And once it's been retrained, you have the option, of course, of continuing your training as you go forward. Perfect. Once you've tested your configuration, you have the option to download a log, and the training succeeded. Once that's been done, you have the option to pre-annotate again based on your newly trained model. And so this is where you would choose all of your non-pre-annotated tasks if you were adding new tasks and wanting to train them on the new data. If you had a lot of tasks here that were incomplete, you could choose that as well. Or if you just wanted to start again and see how the new model performed, you could choose all of your tasks. And that is everything we have on model training. Next, we're going to take a break and we will be back at 11:30 to go over the model testing, which is the next step in the process. And we'll head back for another break, and we will be back at 11:30. Thank you very much for your time. All right, welcome back, everybody. I'm going to go ahead and start off now doing the model training, or sorry, the model testing. After you've trained your model, you might want to test it. So overall, the model testing flow works as such. You have your model that you start training, and then after you've trained it, you may want to test it for bias, robustness, accuracy, and fairness. You run your tests, and if it passed the tests, you're free to release the model, or otherwise we'll augment the data. So today we're going to do, now that we've done the training, we're going to choose our tests, we're going to run our tests, and then we're going to augment our data and retest our data. So you can have a look at test. And here you can see that I've already run a test on this model. And the reason is because it does take a fair amount of time. As a brief overview, however, when you want to start your test, you can just turn on our wizard. And we have the test settings, testing parameters, and then finally the testing will happen. So you'll choose a test suite first, which I will go over momentarily, and your model selection. And the model selection is the language model trained with the tasks so that we can predict the outcomes. Choosing a language model from the dropdown will test against multiple tests and enhance the model through various training iterations. So you can see here, we have ones that have been trained before and the base model as well. Once you hit next, you can filter your completions by, and you can use the tags to filter the tasks that you'll be testing them on as well. You can see here in the past that I've generated 2,785 test cases. You have the option here to see the category of the test, filter test type. You can see that the original, and then you can see that what the test case, what was done with it here as well. You have the option to go in and edit. If necessary, you can accept or reject individual tests, and you have the option to filter at the top here for your categories. Now, speaking of your categories, we asked you to create a test suite earlier, and so we're going to go ahead and do that now. Here you can see that I've done some in the past, but we're going to create a new one. And the same with the test suite, just like the local models or the online models, they're available to be used on any of your projects, which is really convenient. You don't need to do this all the time. You'll need to name your project for the test suite. You have the option to do a description, and you'll of course choose your model type for NER or classification. Now, of course, you must choose your tests. Robustness tests can be added as a matter of course. They check whether a model's predictions are stable under small perturbations in the input. You have the ability to add abbreviations. And we have a minimum pass rate, as well as the proportion of the words to be changed. Here you have the option to set between 0 and 1, or rather a decimal of a percentage to say when exactly each one was passed. Next, you have context, so try adding additional words into the input. And the same idea, it's got a minimum pass rate and the probability. There's also an additional number of parameters, so variations of a sentence to be constructed, some ending context, which you can decide to put in separated by commas, and some starting context as well. The ability to add contractions. So is not versus isn't is a great example of this. Same idea, you have the minimum pass rate and the probability, or sorry, the proportions of words to be changed. Then you have the OCR typo, so it adds, and so this is if you've scanned in an image, a PDF of words, and it's gone through an OCR pipeline. There are some clear typos that are fairly common, and so we'll test for those as well. You have minimum pass rate and the proportion, and as well as the count of parameters. We have the ability to add to test for punctuation. How well does it do with commas, question marks, exclamation points, and so forth. You have your minimum pass rate and the proportion as well. And then we have slang as well. Replaces the words with slang terms. The party was fun versus the shindig. We have the minimum pass rate and the proportion. A speech to text typo is another one that we can test for. The message was clear versus the message is cleat. Minimum pass rate, proportions, but also the parameter, the number of variations of sentence to be constructed. We'll test for typos. Same idea, pass rate, proportion. Adjectives swapping, so exciting, thrilling, scary. Minimum pass rate, proportion. Another test to convert American English to British English. What color is this? What color is this? With color O versus the OU. Of course, this is especially important if you happen to be in Canada or any other country where both are accepted. You have your pass rate and your proportion. And this one will go back from British to American. Dyslexia word swap is helps for words that are spelled slightly incorrectly, where you often see them switched. So you have pass rate and probability. We have lowercase, so somebody who's not putting capitals, numbers to words, which is another good one. This one randomizes the age mentioned in the input, just to see that the age is being picked up correctly. We have instances where the punctuation is not included. We have the title case, which is at the beginning of a header, or using during a header, and as well as we have the uppercase. So robustness is certainly something that can be added very easily, just as a matter of course. The next one that I would think about is accuracy, of course. We have the minimum F1 score, which we've talked about earlier. The test is passed, and you have to choose here the model labels that you would like. So you can choose race or ethnicity, if that's in your taxonomy. And you'll choose an individual F1 score for each of the individual results. For each of the individual entities. This macro F1 score is slightly different, as well as the micro F1 score, and so it just is higher than the configured. You have the precision score, and that tests the precision for each label. So the same idea, you would need to add the individual labels. This is very similar to what you see in the benchmark data. You have your minimum recall score, which again, you have the specific labels for. So for instance, if you knew that the minimum F1 score of medicine in the model that we downloaded earlier, which was oncology, that, let's find it here, hold on. Perfect. So this model name is NER Oncology WIP, and we know the benchmark data here. So cancer score is an excellent one. And we know that the F1 currently, as it sits, is 0.45 with a precision of 1, a recall of 0.29, and a total. So if we were training a model and we wanted to improve on that, we would certainly start there, and then we have the option to go again. You can choose from here to toggle turn all of them on. However, if you don't add the model labels, it won't work, right? And now here I can see that the precision is much lower than expected and the recall score is much higher than expected. So I might choose to change to 0.5, for instance, which is an improvement over the recall score that's listed in the benchmarks. However, it might still be lower than what I want overall. And so you can change that as you will between 0 and 1. The next ones that we have are actually a lot more interesting. They are with regards to bias and fairness. And so this just helps to ensure that your model is without bias. And that's not to say that it is a replacement for data that, for data of people with, of these demographics. However, it's to ensure that there is no incorrect bias just based on the names. And so you can choose to replace Asian last names, Black or Asian first or last names, Black first or last names, Buddhist names, Christian names, female pronouns. You can choose to switch out names for a high income country, Hindu names, Hispanic names, interracial names, Jain names, low income country names, lower middle income country names, male pronouns, Muslim names, Native American names, neutral pronouns, Parsi, Sikh, upper middle income, and white. Same idea, you have your minimum pass rate between 0 and 1. Next is fairness based off of gender. And so this is a gender F1 score. You choose between male and female. And the next is performance. And the performance test assesses the efficiency and speed of a language model's prediction. So once you've chosen the tests that you want, and ensure that we have labels here, and you can add as many as you'd like here, right? You can go ahead and save your test. And it'll be available here. Then when you navigate back to your project, test, and you turn on the wizard, you'll be able to choose your test suite. and then select your model, filter your completions. And so now the testing has been, so if I were to generate test cases from here, this would take the test suite that I just created and create new test cases here that you would then be able to go and review. Once you've finished generating the test cases, you would click Start Testing. And this will generate a new cluster. And you'll go ahead and run your tests. Once the testing is complete, you'll get this nice little test completed, this green bar at the top of your screen. And additionally, you'll have your test names, your model all listed here, and you'll be able to see the results. So you can see the configurations, everything that you chose to test on. You have the option to delete this if you decide you don't want it later, but generally speaking, you do want to keep them here as a matter of course. And now the interesting thing, of course, the results. So here we have a graph up at the top that you can toggle on and off. And you can filter down based on the categories that you chose from. So for instance, the accuracy. You have an option to have a look at the failure rate, the pass rate, the test types and categories. You'll scroll down here and you can have a look at the pass and fail of each category and test, pass rate, and what the minimum was configured to so that you can see if it improved or not over time. And then you have a detailed report for each individual test that was there. You can also download a log. So you've created a project, you've trained your data, you've trained your model, sorry. You have, you've run your tests. Now you want to improve your results, but you don't necessarily have the data to do this entire experiment again. So we can improve our test results with augmented data. And so we have two types of augmented tasks. We have augmented, which uses proportional or templatic augmentation, and we have synthetic. And so synthetic uses ChatGPT, and the quality of your tasks depends on the quality of your prompt. The same way that ChatGPT is used anywhere else. In order to do this for the synthetic tasks, which is what we will start with, you will need to set your parameters for the integration, and this does require an OpenAI account, and so you'll enter your secret key and you'll have it validated. You'll select your temperature between 0 and 1, and so this temperature here is referring to the randomness of the generated responses. And you'll select the number of texts you want to generate, and so you'll see this number here changes this number here. Once you've chosen the amount of results that you want to generate, you will click Generate Task. And my key is not listed here, but I will grab it in just a moment, and we will be able to generate tasks. And then you have the option to choose which ones you want. You choose a tag for them. So synthetic is automatically added, but you have the option to add any of the other tags that are also available on your model. And then you just click import, and it's as simple as that. For the augmented data, this will automatically choose a proportional augmentation that is based on the results of your tests. So if we go back to our test and we show the results, we see that it failed robustness for the title case specifically. And so we can, when we click on improve test results, it's going to automatically choose robustness at a maximum proportion. So you can choose whether you want a default increase, a moderate increase, notable, etc. Choose to apply it to all. And you can see the test types that it's adding here. So proportional augmentation versus templatic augmentation. So templatic augmentation requires that you already have a template. You could also generate templates via OpenAPI. So you can manually add templates based on the available labels that are listed here that are chosen in the project earlier. Right, so you can just go ahead and so all you're doing is adding a string of text that uses the labels that are available here, and you click Add Template. So I would go right, and you can add more than one. Now this assumes that I have organization in here. I do not. But I do have alcohol and direction. You can select the number of results to generate for each template, or you can choose to generate the templates specifically with OpenAI. You'll choose to generate your results, and that will happen fairly quickly, actually. Once they load, we will simply select our tasks we want to have a look at. We can choose granularly or to add them all, and then we will select to import. Here I've already imported a number of tasks, and you can see that they're tagged with synthetic. Right, and you can see that I've already run a pre-annotation server on them as well. To get to the import task page, simply go from the top here, and you can view. Perfect. So we can see that there's already a number of results that have been generated. So in this case, we're going to go ahead and select all, import. Perfect. So we've added those tasks in. Now you can see that these have been submitted, but they have not been pre-annotated outside of what we've already chosen from the template itself. So since we've only added test cases for those specific models that we were trying to train, we can then again add our pre-annotation server and go ahead and pre-annotate our tasks the same way that we did before. From there, we would want to manually review. That's our human in the loop. We would go ahead and train again, and then we could go ahead and test again. So why would you choose to use augmented data? It's obviously HIPAA compliant. It's designed to fill holes in the original data set, and it generates additional possible cases the model can use to improve itself. Here's a better representation of the templatic augmentation that I mentioned earlier, right? Is that you have, I live in location, suffering with disease, you choose your label, right? And then it will fill in new words and create new test cases. Of course, we have the synthetic tasks, and prompt writing has become really a little bit of its own challenge in 2024. Is that, but I'm sure we've all played around with ChatGPT in the past, and we're aware that better results can come with more specific prompts. And there is a test prompt that has been already plugged in to help you get the maximum amount of use out of each result. So visually comparing the results between your tests, you should hopefully see a notable increase. So for here, here's 2 that I have done earlier, and we've based on the same 23 test categories and test types. You can see that my original test had 78% passing rate, and now we have an 89% pass rate, which decreases the failure rate approximately 10%. So that brings me to the end of my training and augmentation section. I am going to pass it back off to Andre to have a little chat with regards to PDF annotation.
Thank you, Jessica. That was very comprehensive. So besides text and ER annotations, we can also annotate PDFs, and I would like to demonstrate how the tool that we have is dealing with such kind of annotations. Okay. It also allows at the end of your annotations to train model inside NLP Lab and Generative. Okay. Let me change the screen right now. Okay. Okay, setting up the project is implying the same steps that I've shown you for and at the beginning of our training. And once you uploaded your PDFs, I will show you a sample of a PDF. Let me find a PDF that's not annotated for this purpose. This is a general law. When you are presenting something, everything is loading slower. Happens also during practice. We also have live surgeries, for example, and things go wrong in those surgeries usually. And right now, okay. So this is a PDF, a sample PDF. We used it for a financial project that we had, and I would like to show you how a user can interact and annotate data inside a PDF. Here I can scroll through the pages of this PDF, and up here I am presented with a taxonomy. Let's say I want to annotate the title here. First of all, I do have some settings that are specific to visual NER, and those settings are allowing me or the user to edit the bounding boxes that I use for annotations, and I also select them to allow user for custom selection of regions. Let me explain you what those are. So annotating, let's say the title, I select this item from my taxonomy, and I am allowed to draw a box around the entity that I want extracted, and at the end it is at the end I can see the region annotated here, what are its position, X and Y axis, and I can also do cross-line annotations. So for example, let me find a task that this is the box actually. Let me find a task that I can exemplify a cross-line annotation on. Okay, not this one. Cross-line annotations mean I can annotate the line entirely from a table, and so okay, not a good example. Please allow me 1 second. Okay. Okay, I think this is a good example to demonstrate the cross-line. First of all, I'm selecting my initial item from the taxonomy. Let's say I want to annotate this entire row. I hold Shift, I click the item, and it should allow me to annotate the entire, come on. When I want to demonstrate, and of course it's bugging on me, but this is due to the PDF and not to the setup we have. Let's try with a hard refresh. It should refresh the interface. Okay, it seems I cannot demonstrate it right now. What I want you to see is that a PDF that's annotated for contractual and financial reasons looks like this. I can edit, for example, this annotation of our colleague here, and I can also, let's say, add more annotations for these items, change it to different other annotations, and in the end, when I have the file done, I update, and I can easily train, as Jessica has shown you, I can easily train it inside our tool. I set some training parameters, and I simply press train model. This takes a little bit longer. The PDF takes a little bit longer, but this is the way we can annotate PDFs. And we exercise with some medical files, and this it's harder to work on for the annotator, but it's easier in terms of setting up the project, and you don't have to use the OCR tool to transform a file. So PDF is an alternative for us. Okay, that's what I wanted to show, Jessica. Thank you.
Perfect. Thank you so much for demonstrating that. The last step I am going to show you guys is where you can find all of the resources if you guys need any help with using the product, as well as where you can go to install and get everything ready. And then before we head into our Q&A, I would love to do a demonstration of a brand new feature that we are rolling out. The improvements to de-identification is that this is a little bit of a preview. It's not yet ready for deployment, but we are very, very close, and it's definitely ready for a demonstration. So I'm going to go ahead and share my screen. Oh. So now that we've very thoroughly gone over the types of projects that you have, as well as the hub, I will just briefly touch on the settings that are available for everybody here. So you can choose create new users here, which I believe was covered during the project creation side, as well as you have the option to import a license if you already have a license key, is that you can obviously download it from the MyJSL login page, or you can drag and drop your license files here, or just copy the key. We have the existing licenses that are available to see here, and if you need a license, you can provide the following details. The analytics requests, of course, will come here for an admin user. You'll be able to see that we've granted projects, permission has been granted for a number of things, and the reason for this is that the analytics run constantly, and so it's a good hygiene practice to grant as needed, but also revoke as needed as well. So we have a very robust API integration, which is really fantastic if you are migrating into or out of Generative AI Lab, or doing anything with regards to your projects. So you can clone, backup, import, authenticate. You have your project groups, as well as your, you can basically do anything that you could have done through the UI in the project through the API as well, which is really fantastic for those of us who are already very into their code. Of course, as I've shown here earlier, we have the cluster, or just basically the servers that are running in order to make everything happen. And then we have our system settings. So you can disable export if you don't want any of your other users to be able to export tasks or projects or anything of that nature. Just one moment while I let the dog out. Sorry about that. That seems to be better now. We have a number of server settings. You can choose your maximum amount of active servers, a memory limits for the CPU resources, as well for the training server, as well as the pre-annotation servers. We have backups that are available. You can do the backups for your databases or to your files. You can choose what you want to back up on. This is set for AWS S3. And you can choose obviously the backup now. There's also a number of integrations available. As mentioned, the OpenAI one that we mentioned earlier, is that you can see all of this available here. Now, if you are interested in seeing any information about your account, password, authenticator, and integrations that are available just to your user, that's all available here. Any information about your current version of Gen AI Lab is available on the About page, which is really useful for troubleshooting, especially if you would like to contact support. And then, of course, you can log out. Now, the thing that I would really love to highlight here is our help form. So because I'm based on the About page, it'll default to getting started. However, the help page will actually go to the correct place based on where you are. So here now I am in tasks. And so this will go to the tasks page of the help file, and therefore you can see any information that we have about task assignment. You can see video demonstrations, information about assigning, the task status for annotators, etc. And so this is the first place that we like to send people if they are looking for help. This resolves, I would say, about half of the inquiries that we get. However, there are plenty of times where we don't support whatever it is that you would like to do with your specific project in mind. And I would like to implore everybody at this time to please feel free to write to us, email, Slack as well. And we're always happy to help with any debugging issues, as well as with any new feature requests. We're happy to have a look and prioritize. I know a few of them have already gone into the chat as well. The next place for resources that I would ask you to go, especially if you're having trouble with our with the quiz that follows this, is to go to nlp.johnsnowlabs.com. And so from our website, you can go to resources, and you'll be able to find us there. So from nlplab.johnsnowlabs.com, of course, you can find information on the Generative AI Lab, information on the installation, resources for the Models Hub, the models, embedding, and so forth. We are available for installation via AWS and Azure, a few other types as well. The previous iteration of this project was called NLP Lab, which you'll sometimes see it referred to as well. NLP Lab is being sunsetted by the end of 2024. And as a result of that, we are asking people to upgrade to Generative AI Lab. The upgrade process is the same as it has been in the past. For on-prem, you will need to do a fresh installation for AWS and Azure. And instructions for that are coming soon. And we have a lot of different information with regards to manual annotation, entity resolutions, just different types of annotation that are available, the model training, and as well as the administration. We also have a variety of video tutorials that are available here. And of course, if you would like, in addition to the 2-week trial that is available as a result of this training today, if you would like any demonstrations for things that are specific to your task, we are also absolutely available for that as well. And you can have a look at us and find us in your favorite marketplaces, AWS and Azure, of course. So with today, the resources that will be available today will be coming via email, as well as the credentials. You'll be able to sign in using this IP address, which is open. And of course, as mentioned, we are available through Slack and email for support. Just to round up the conclusions from today before I get into our new demonstration, is that we have the manual annotation process, the best practices for efficient and coherent annotations, project templates and project configurations that suit your project. Reuse pre-trained resources for faster and more efficient results, detect annotation errors with analytics, and train models to learn common tasks. Perfect. So if you give me just one moment, I'm going to pull up the box that is for the newest version of our product. I'm very excited to share this with you guys. But first, actually, I will show you what our current de-identification process is. So when you go and create a new project, you have the option straight from here at project creation to choose de-identification. So when you choose de-identification, these options become available for you. And you have your masked with entity levels, your masked with characters, maxed with fixed length characters, and obfuscation. And of course, you must name your project. You'll add your team members as normal. And then we currently offer de-identification for NER projects. So yes, you want to overwrite, and you do want to save. Once that's done, you'll click next again. And here's where you choose what gets de-identified. Again, you have the same entire project or relevant sections, but you're choosing your own models, rules, and prompts. So the models in particular for de-identification will be based on what you choose here. And there are some de-identification models available in the hub currently. Then you'll configure the rest of your project as you normally would for a regular de-identification project. Now, the important thing is that when you are viewing the tasks for a de-identification project, you should ensure that everybody who is viewing them has the ability to see the data, because the de-identified data will not become completely de-identified until, this is a new project, of course. It will not become de-identified until the data is complete, until it's been exported, right? And so you can see this de-identification test. This is a de-identification project, and this is, you can see this from the main screen so that you know that it potentially contains sensitive data. And so you'll see here when you have a de-identified task, right? And you can see here that it's not perfect, right? When we deployed the pre-annotation server here, which is what does the pre-annotations for the de-identification, you can see that it hit medical record, patient, age, city, but it missed the email here. And so that's why we have set up de-identification projects like this, because of the manual requirement, just in case. When you export a de-identification task, you export with de-identification, and then you'll be able to see how what it looks like when it's been properly de-identified. And because I am not sharing the entirety of, I'm only sharing the tab, if you'll give me just a moment, I'm going to share a new tab that has some better demonstrations, and then we'll get into the new way of handling things. And there's a lot more functionality that's available. All right, so from this window, and this is just de-identify.johnsonlabs.com, DEID, you're able to have a look here, but you can see the difference between masked text and obfuscated text here. Now, this is our test box here that we have available for this demonstration. And so to create a new project, you'll see that it's a fair bit different. And you'll see that the de-identification feature has been moved here. And you'll select de-identification from here. So you'll save your configuration. And continue on. It's the same idea here for the entire document and the relevant sections. However, our de-identification pipeline has been pre-loaded with the clinical de-identification pipeline. So you can see here it's got all of the information that you would typically find in a HIPAA compliant de-identify document. And so you continue on with next, and you get to choose your so you can choose your masked settings the same way that you could before, right? You're maxed with entity levels for characters, fixed length characters, but you also have the option to choose it at an entity level. And so here we have, you can choose whether you wanted each entity to be obfuscated or masked. And additionally, we have some features with regards to age. So the obfuscated age settings will drop down the ability to choose the age range for each toddler, child, teen, adult, middle-aged adult, or a senior adult. Alternatively, you could say that you wanted everything to be masked with entity levels labels, but medical record name that needed to be done with fixed length characters. The other one that we have, of course, is date. And so within each date, for each of your tasks, the date will be adjusted accordingly. So say the date of admission was today, October 4th, and we are obfuscating that and that becomes September 28th. That date will still be 2 days off, or if we choose whatever we choose, so we choose our obfuscation, we shift by this range within the task, it will be the same shifted date. So then you won't end up with any confusion, say if a patient is discharged before they were admitted or anything like that, everything stays consistent. And then you have your same configuration options that you had for manual annotation are still available here. So make sure you save. And then the nice thing when you deploy a de-identification server, project, apologies, the pre-annotation server automatically deploys to save you some time later, because the purpose of a de-identification project is to de-identify. Here I've used the amount of servers that I have available because I have already done a task with this, so there is already one available. So this is successfully saved. And then the same way that we would before, I'm going to go into an existing task here to demonstrate. Right, just de-identify all tasks. And since it wasn't created on this project, it won't work. And so that's why we want to make sure that we go ahead and go into our clusters here. And we're just going to delete one. And then we can go back and recreate on our project. We'll give it a moment to deploy. I find that I'm always impatient. And you can see that it's still busy here. Another nice way of going about watching your servers is by going to the cluster page, as mentioned earlier, and you can see it's still busy, but we can toggle on auto refresh from here and wait a moment. And we'll just give that one moment to go so that I can continue on. All right, in the interest of time, as much as I like things to be done as soon as I'm ready for them, that is simply not the case, especially as these text test boxes tend to be a little bit smaller. And so, as mentioned, when you de-identify once it's been run, you'll be able to see your tasks the exact same way. So I don't need to go out and in, of course. I can click the next button. Right, and we can see that email is being consistently left out, and that would be something we would train it on, but our newest pipeline is much more robust than the one that's currently here. And you also have the option to see your pipelines here the same way that you would your models tests and rules and prompts. And so that's nice. And so obviously the de-identification happens here. Currently it is available for the free text, and the documents and DICOM are available using the de-identification license, and not currently through GenAI, but we're coming on it. Is that we're always excited to be adding new tools, and if there is any use case that you have that you think doesn't quite fit into what's available here, we would love to hear about it. I'm going to go back to the presentation now, if you'll give me just one moment. And so just to head back to the training resources very quickly, the username and password for your generative AI box will be coming to you via email. It will also include a copy of the annotation guidelines, as well as some of the resources that are available via GitHub. It will be available for 2 weeks, so please use it as much as you can and want to, and see if it works for your purposes. I recommend having a look through the information that is available at nlp.johnsnowlabs.com. It will contain the answers to your quiz, which will be available shortly as well. The quiz is a 20-question multiple choice test. You will have 2 options to pass. You're not able to go back after a question has been answered. I do apologize, but after that, you will have the option to go twice. And I certainly like to talk quickly because we seem to be finished a little bit ahead of schedule. I would love to open up the floor for some questions and discussions on some of our newest features, and if there was anything that anybody else wanted a little bit more clarification on.